Next, Introduction to Encapsulation. Encapsulation is one of the 4 fundamental principles of object-oriented programming, OOP. It refers to the bundling of data, attributes, and methods, functions, that operate on the data within a single unit or class. Encapsulation serves to protect the internal state of an object from unintended interference and misuse by restricting direct access to some of its components. This is achieved through the use of access modifiers. Don't worry if this feels new at first. This section covers access modifiers in Java. In Java, access modifiers are keywords that set the accessibility visibility of classes, methods, and variables. The 4 main access modifiers are, you'll see a few items listed here. First, public. The member is accessible from any other class. Next, private. The member is accessible only within its own class. Also, protected. The member is accessible within its own package and by subclasses. Take a moment to read the rest on screen. Why use encapsulation? Let's dig in. Encapsulation provides several benefits. Let's walk through the main points. First, data hiding. It restricts access to the internal state of an object, preventing unauthorized changes. Next, controlled access. It allows the class to control how its data is accessed and modified through getter and setter methods. Also, improved maintenance. It minimizes the impact of changes within a class, making code easier to maintain and adapt. The full list is on the slide if you want to review it. Let's move on to implementing encapsulation with a Java example. Let's look at a concrete example to see how encapsulation works in Java. This slide introduces a class definition. Study the structure in the code sample. Now, explanation of the bank account example. In the example above, we have a bank account class that encapsulates the account number and balance. The following points highlight the use of encapsulation. First, the account number and balance variables are declared as private, meaning they can't be accessed directly from outside the class. Next, public methods getAccountNumber and getBalance allow read-only access to these variables, while methods deposit and withdraw provide controlled access for modifying the balance. Also, by checking the validity of the operation, e.g. ensuring the amount to withdraw doesn't exceed the balance, we further enhance data integrity. Of key concepts. In this lesson, we explored the concept of encapsulation in Java, including, first, the definition and importance of encapsulation in OOP. Next, the 4 types of access modifiers: public, private, protected, and default. Also, a practical example of encapsulation using a bank account class to manage account data securely. Now put what you've learned into practice. You'll see a few items listed here. First, create a new class called person with private attributes name and age. Next, add public getter and setter methods for these attributes. Also, include validation in the setter method for age to ensure it can't be set to a negative number. Take a moment to read the rest on screen.